Bismillahirrahmanirrahim. Assalamu Alaikum. Dear student, welcome to my YouTube channel. Today we will start new syllabus Physics SSC-2 KPK Book Foundation Unit number 3 Dynamics. Today we will discuss about SLO base according to FBISE requirement numerical problem. Question number 9 to 12 in part 3. In previous part, we will discuss question number 4 to 8. Now we will start question number 9 to 12. In our today lesson, numerical problem, question number 9, given statement. Find the acceleration produced in engine. Force of 3500 Newton in a car of mass 600 kg and truck of mass 2400 kg. Now, according to the given statement, write given data. Force F is equal to 3500 Newton and mass of car M1 is equal to 600 kg and mass of truck M2 is equal to 2400 kg. Now we can find acceleration produced in car A1 and acceleration produced in truck A2 is equal to question mark. Solution. First of all, we find the acceleration in car A1 by using the formula according to the Newton's second law of motion. F is equal to ma, or we can write that F is equal to m1 A1. Now putting the values, then A1 is equal to F over m1. Then F is equal to 3500 divided by mass of car 600. Now 3500 divided by 600 is equal to 5.83 meter per second square. So the acceleration in car is 5.83 meter per second square. Now we can find the acceleration produced in truck. So A2 using the formula according to the Newton's second law of motion. F is equal to ma, or we can write that F is equal to m2 A2. Here A2 is equal to F upon m2. Now putting the values, then A2 is equal to F, the value of force is 3500 divided by mass of truck 2400. Now dividing 3500 by 2400, so the acceleration produced in truck is 1.46 meter per second square. Now we can move next numerical problem, question number 10. In question number 10, given statement, the weight of an astronaut and his space set on the moon is only 250 Newton. How much do the weight on Earth? What is the mass of the moon on the Earth? Now, the acceleration due to the gravity for the Earth GE is equal to 9.8 meter per second square, and at a moon the gravitational acceleration, or also called acceleration due to gravity, GM is equal to 1.6 meter per second square. First of all, write the given data. Given data, weight of astronaut on moon W is equal to 250 Newton. Now, the acceleration due to the gravity on moon GE and GM. So, acceleration due to the gravity on Earth GE is equal to 9.8 meter per second square, and acceleration due to gravity on moon GM is equal to 1.6 meter per second square. So according to the statement, we can find mass on moon mm is equal to question mark, and also mass on earth me is equal to question mark. Also we can determine weight on earth we is equal to question mark. First of all, we can find that the solution W is equal to mg. So W is equal to mass of moon multiplied by mass of gravity. This implies that mass of moon is equal to weight divided by gravity of moon. So we can putting the values, weight is equal to 250 divided by acceleration due to gravity of moon 1.6. So the mass of moon is equal to 250 divided by 1.6 is equal to 150 kg. Now we can find the mass on earth. Now the mass on earth we can calculate using the same formula. As mass is a constant in everywhere, so mass of astronomy on earth is also same 1.156 kg, because mass cannot be changed, because gravity change are also same but mass is remain constant. So in C part, weight will be changed, then we can find the weight. So for finding weight we, we know that weight on earth we is equal to mass on earth multiplied by gravitational acceleration ge. Now putting the values, then weight on earth is equal to 156 multiplied by 9.8. Then the answer of weight we on earth is equal to 1528.8 Newton. That is approximately equal to 1.528 multiplied by 10 raised to power 3 Newton. So the weight on earth is 1.528 multiplied by 10 raised to power 3 Newton is the weight of body. Now we can find next numerical problem in question number 11. In question number 11, given statement, the fast recorder speed of golf ball hit at the golfer is 75.8 meter per second. We can convert this answer in given statement to 73 kilometer per hour. If the mass of golf ball is 46 gram, what is the magnitude of its momentum? Now, according to the given statement, velocity v is equal to 75.8 meter per second and mass m is equal to 46 gram. So we can convert gram into kilogram, then 46 divided by 1000. Now the mass m is equal to 0.046 kg. Then we can find the momentum, that is denoted by P. So according to the given statement, momentum is product of mass and velocity. We know that momentum P is equal to mv. So according to their definition, momentum is equal to mass multiplied by velocity. Product of mass and velocity is called momentum. Now putting the values, then P is equal to 0.046 multiplied by 75.8. Then the momentum of body P is equal to 3.4868 Newton per second. The SI unit of momentum is Newton second. So the momentum P is equal to 3.4868 Newton second. Now we can find the momentum is P is equal to 3.49 Newton second. Then in last numerical, so numerical problem question number 12. Calculate the force required to stop a car of mass 1200 kg and a loaded truck of mass 9000 kg in 2 seconds if they are moving with a same velocity 10 meter per second. So, according to the given statement, write given data. Mass of car M1 is equal to 1200 kg and mass of truck M2 is equal to 9000 kg. Now, the time t is equal to 2 seconds. Initial velocity Vi is equal to 10 meter per second and final velocity body will be stopped, so Vf is equal to 0 meter per second. According to the given statement, we can find force required to stop a car F1, that is equal to question mark, and also force required to stop a truck F2 also is a question mark. Both are fine. Now, first of all, we can find the acceleration by using the first equation of motion. In first equation of motion, Vf is equal to Vi plus At. Putting the values, then Vf is equal to 0, Vi is equal to 10 plus A 2 can find and T is 2 seconds. Now putting the value 0 is equal to 10 plus 2 into A. Then acceleration A is equal to minus 5 meter per second square and negative sign shows the deceleration or also negative acceleration. So now we can putting the values of A and find the value of F1. According to the Newton's second law of motion, F is equal to ma, then F1 is equal to m1a. This implies that F1 is equal to 1200 multiplied by minus 5, that is equal to minus 6000 Newton. Similarly, we can find the force F2 by using the Newton's second law of motion. F2 is equal to m2a. Then putting the values of mass and acceleration, then 9000 multiplied by minus 5, that is equal to 45,000. So the answer of F2 is 45,000 Newton. So force required to stop a car is minus 6000 Newton and force required to stop a truck is minus 45,000 Newton. For other videos, subscribe our channel. Best of luck. Take care. Allah.